So in our previous video, we've shown how to draw the bearing in GeoGebra. So that was a nice visualization. We're going to continue with this problem. If you want to practice it yourself, give it a go, pause this video, and then get back to it. So an airline operates between three locations, A, B, and C. And B is located 530 kilometers, as we can see on the sketch, from A on a bearing of 248 degrees. I'll write this down. C is located 300 kilometers due east from the midpoint M of AB. And we have this information as well, 300 kilometers. And we need to calculate the distance AC. Right. Now we can start by extending the segment AN. We will be able to figure out one of the angles. And if I extend that segment AN, then I create a right angle triangle. And I also know that this angle here will be 248 degrees minus 180 degrees. And that is because this angle over here, maybe I'll change the color. This angle over here is a straight angle, so that's 180 degrees, which is this one here, and the bearing is 248 degrees. That means the rest will be 68 degrees, and that will be the 68-degree angle. I have another right angle, and what I'm looking here is the line M. I'm going to call this O. So I'm trying to find out MO. Now, using the trigonometric ratios, I will use the sine of 68. Now I'm dealing with this triangle over here, MAO triangle. And I am going to find the side MO. So sine of 68, that will give me the MO. The sine is opposite over hypotenuse, and I know that hypotenuse is MA, which is half of 530 kilometers, because M is the midpoint. So half of 530, that will give me 265 kilometers. So that will be MO opposite over hypotenuse, which is MA. So sine 68 is MO over 265. Using our algebraic skills, MO is equivalent to 265 times sine of 68 degrees. MO, the side MO, it will be 245.7 kilometers. That's the side MO. Now, since we know that MC, the distance MC is 300 kilometers, we can find the distance OC, which is 300 minus the distance MO, which is 245.7. And that will give me the distance OC, which is 54.3 kilometers. Altogether is 300 kilometers. Since we found MO and OC, we can use the triangle OAC. Now, using this information, I will be able to find the side AO. Once I find the side AO and I know also the side OC, I will be able to find AC, the distance AC. Now, there's two ways of finding AO. You can either use Pythagorean theorem or you can use the trigonometric ratios. I will use the trigonometric ratio cosine in this case. So cos of 68 degrees, cosine adjacent over hypotenuse. Well, I'm trying to find the adjacent, which is AO, and the hypotenuse is MA, which is 265 kilometers. So cos 68 degrees we know that AO will be equivalent to 265 times cos 68. And we know that AO is 99.27 kilometers. Now we know AO, we know OC, AO, OC, we will be able to find AC. Now, we will be using the Pythagorean theorem to find AC, since we're dealing with a right angle triangle, the triangle AOC. So AC squared is equivalent to OC squared plus OA squared. AC squared, it will be equivalent to OC, so 54.3 squared plus OA 99.27. AC will be equivalent to the square root of 54.3 squared plus 99.27 squared. Now, using our calculator, this will give me that AC is 113.15 kilometers. And this is our answer. So the distance AC is 113.15 kilometers.